In this video, I'm going to show you how to do an expected value calculation from section 6.1. I'm going to be using a problem from page 342 as my example, and as you page over to that, take a look very carefully at the examples in that section and at the problem set. You'll notice that there are probability distributions all over the place. And it's an important thing to notice because I think the number one error that many students make when they're working on expected value, and this is something that makes it a lot more slippery than it needs to be, is they don't bother to write out the probability distribution that's associated with whatever situation they're working on. You really need to see that distribution clearly in order to calculate the expected value easily. So the problem I'm going to use as an example here is number 30. It's on page 342 and it says as follows. A life insurance company sells a $250,000 one-year term life insurance policy to a 20-year-old male for $350. According to the National Vital Statistics Report, the probability that the male survives the year is 0.998734. Compute and interpret the expected value of this policy to the insurance company. Now those last few words in the problem are crucial. It says to the insurance company, and that means that we're calculating according to the insurance company's cash flow perspective, not from the policyholder. So I'd like to use the lists in order to make the distribution plain. So I'm going to go to the stat menu here, and I need to key in some information into some of the lists here. Let's use list 1. We'll use this for the probabilities associated with things. For the first entry, I'm going to put the probability that the guy survives the year. So that would be 0.998734. And the probability that he dies would be 1 minus that. It's the complement. So 1 minus 0.998734. Now list 2 is going to be used to hold the cash flow items. And so from the insurance company's perspective, in order to buy this policy, they take in a $350 premium. Now that's income, and that's considered positive cash flow. So I'll just put 350 there. And in the event of his death, they have to pay out a $250,000 death benefit. Now that's outflow, and so that would be a negative number, but it's less the 350 that they took in as part of the premium. So I want to just calculate the value here. I'll just do 350 minus 250,000. And you can see it right there. Now it's represented in the calculator as scientific notation, but that's fine. Now we can do the rest of the calculation using list ops, because in order to calculate the expected value, we want to take the probability of living times the cash flow associated with that and add that to the probability of dying times the cash flow associated with that. And so the easiest way to do that would be to go over to list 3, and then we'll simply say that list 3 is equal to list 1 times list 2. And it automatically populates the list with the result. And I need to add those together, and the lazy, easy way to do that would be to go over to list 4 and to use list ops to get us a sum. So I'll go to the ops menu here, and I can use number 6 probably the most easily. That's a cumulative sum. It just adds up the elements in the list right there. So I'll take a cumulative sum of list 3, and that's adding up everything in list 3, and you can see the result right here. And this number, let me highlight it. That number you can see highlighted right there, 3350. That's your expected value right there. And you could do the same calculation by hand if you wanted to. It would look a little bit differently. Let me quit this here and I'll show you how it would look by hand. You would take the probability of the guy living, 998,734. You'd multiply that by the associated cash flow, which would be an income of $350. You'd add that to the probability of him dying, so we can calculate that. That would be 1 minus 0.998734. And we would multiply that by the associated cash flow, which would be the $250,000 death benefit less the $350 premium. So 350, or well, I need a parenthesis there in order to make sure I capture the calculation in its entirety. So 350 minus 250,000. And that's how the calculation would look if you did it by hand. I think you have to agree it's a little bit more trouble to use the list, but it does give you the advantage of visualizing the distribution and automatically getting the result. So I'll do a few more examples of expected value in other videos, but I hope that is helpful. Please look carefully at this in the book and try to match the answer on your own.